Okay. As I mentioned that I always do that type of thing. So I'm going to finalize. I'm going to bring an end of the whole material that I've studied from week 1 to week 4 by going through some revision of the all the tutorial questions. As I promised you that I'll be going to give you all the tutorial questions. These are all here. Now, keeping in mind, when I'm going to show your assignment, this assignment was made by Samarpan, very clever person. So when I'm going to show the assignment, it covers all the things that we learned from week 1 to week 5. It covers all the things. So I'm going to discuss the assignment today as well. Okay, but let's have a bit of revision of all the. I'm not going to go through each and every individual thing, but I'm just going to revise all the tutorial questions, and keeping in mind these are actually not our solutions. These are actually copy paste from my student solutions. So whenever students read it, we copy that thing, we put that thing, and that is a solution. Okay, so I don't need to create this type of solution by means because our students can make this type of solution very easily. Okay, let me see if this recording now. Yes, it's recording. Now, if you see the first problem, remember we have asked you that to find the largest and the smallest of three numbers, 1, 2, 3. So largest is 3 and smallest is 1. So remember, we have defined three variables, first, second, third. As you can see, we have used some comments as well, but these are too many comments, right? User will input. I mean, you don't need all, it is too messy. I mean, you don't need to put comments for each and every same line that does the same operation. In order to make a nice, really nice looking code, you can make one comment for one and that's enough, okay? Or you can create a block of comments for a block of code, that's it. But not like for every line, but that's fine. Now you can see, so you know that enter the first number, input, integer, convert into integer, store in the first variable, second variable, third variable. Then what I'm saying, print maximum, I'm going to print the maximum, and I'm going to use a function called max, which is a built-in function, first, second, third. So it will print the maximum, which is 3. Similarly, it will print the minimum, which is 1. Clear? Solution. This is the first week, first tutorial that you have done. Yes or no? Okay, those who don't understand, that means a problem, and those who understand, this is simple, straightforward. Next, there's another question actually I've asked you in the solution that I got over here is something good, but I'll never give full mark for this type of solutions. Why? I'm going to say that thing as well a little bit. So just have an understanding why. I mean, this is okay. You're using maximum function and minimum function. That's it, and that's nice. There's no problem. You have done that thing. But anyway, I'm not going to give you. I'll not be happy if I see all the comments every line by line. So make it clean and tidy. The much better it is. The much nicer it is. The much better it is for us to mark. So what I have done over here, I have created a Python program. I asked them a Python program that will print the following, which is 1, 3, 5, 7, 9, 11, and then after that 10, 8, 6, 4, 2, and 0. So the first one will be 1, 3, 5, 7, 9, 11, and the next one is 10, 8, 6, 4, 2, and 0. Okay. I told them the hint that after 11, once you reach the 11, can you subtract the number by 1, go to the next line, and then again subtract by 2. So that was the concept. I wanted to do it. Once you hit 11, then once it reaches the upper limit, you reduce 1 from the 11, so make it 10, and then from the next time it will be by 2 reduction. So 10, 8, 6, 4, 2, and 0. But both the solution that I got over here is pretty much, I mean, hard coded. In the first line, I will print all those. In the second line, I will print all those. So there is nothing, there's no transition, there's no logic that I've used how to change from 11 to 10. So that is where actually you lose mark. If I ask you to do that type of thing, do that. Because yeah, this is correct. This will be perfectly correct. But the problem is that it doesn't gives you the logic that I would like to see in your small logic. This is actually in week 1, I think, week 1 or week 2 tutorial. Small logic, but it is important for us to know. So what they have done, you can see, they use this for loop, okay, and they put end equals to space, so everything is space, and first number set plus 2. So 1 plus 2 is 3 plus 5, 7, 9, 11. 6 times they had finished it. Clear? This is straightforward. Then what they have done, they deliberately put a new line. So they went to the next line. Okay. Again, they created another second sum, and what they have done, they have deliberately put it 11 minus 1. I didn't want to, I wanted to see whether once it hits 11, it automatically reduces to -1. Because right now what is happening, guys, listen to me, guys. Right now, what is happening actually? It is hard coded to 11 only. Now, if I say that, okay, I can take number till 20, 21 or till 31 or till 51, the number can be changed. So over here, this will be always 11 minus 1. It will not be 31 minus 1, right? Because you have hard coded that thing. So that's why the beauty of this thing, you find the what is the higher limit, the last limit of that you want to go. Once you go to the last limit, you reduce the last limit by -1, and then after that you do the operation. Over here, what they have done, they have used 11, hard-coded 11 minus 1. Again, they uses the range end, and then they put -2. So 10 minus 2 is 8, 6, 4, 2, and 0. In this way, they have done it. Yeah, the program will work perfectly all right. There's no problem. The only problem is that the they didn't look into the higher limit, how to cross check that higher limit. 11 is the higher limit. They could have used an if function, that if the counter reaches 11, then we reduce it to -1 and then go. In that way, what will happen? Then we can change that 11 to any other number, right? If the counter reaches to n, right? If my counter is greater than or equal to 11, or 11 was there initially, but you can change to 11 to n, any sort of number you can put. So if that condition was there, it was much more easier for us to do. But this code is perfectly all right. But the mark will lose, they will lose the mark because of only one reason, because they make it a hard-coded sort of coding. They could have used a if condition, that if it reaches the last value of the range, then we reduce it by 1, and then again it reduces by 2. Understood what I said over here, guys? Clear? Understood. Very good. The next one, what they have done, this is another person, they learned about range, or range. So what they have done, so they moved from 1 to 12 minus 1 to 1 to 11, and then every time they're incrementing by step size by 2. So 1, 3, 5, 7, 9, and 11. And 13 it will not print because it is beyond 12. Done. Then print a new line. Again, say bottom one, so what they did, say they move from 10 till -1 because it goes till 0, and then everything will go to -2. So 10, 8, 6, in that way it went on. Now, perfectly all right, there's no problem. But there is no logic behind it to check for the upper limit and the lower limit. So whenever you do the coding, you have to make this coding efficient in a way so that it's scalable. Right now, you're working with 10 or 11 or 15 or 20. But next time when I'm going to ask you that this 15 can be n, it can be 100, 200, 500, 1000, or 1000, okay? You cannot actually use this type of hard-coded 10 minus 1 minus 2. You can do that whole thing, right? So the more you make it scalable, the more you make it generalized, the more better it is actually in terms of coding and get the flexibility of the coding as well. Okay, good. Then I think you know already about this odd and even number, right? So if the remainder is 0, then it's even. If the remainder is not, it's an odd, and they check how many odd and even numbers are there. So that's a simple thing that you can easily do it. There's no rocket science over here. But one good thing I like over here is that they put the right variable, but they didn't put any comments over here. You can have one comment over here actually. What this particular function is doing, people would like to know. Because you think in this way that other than that, everything is quite simple. But some people want to understand what is the percentage modulo operator, because it is something that we always forget, right? So you can put a comment. This particular one checks for the reminder. So this is a good thing for the people to understand. If it comes to you as well, you will find it out that there are so many small syntax that you will forget. Okay, but there are some big syntaxes. You'll never forget this type of syntaxes. They're very easy. But this is percentage, and there is called one modulo. Okay, there's one called division. So there are small operators that you might forget. So you could have written one single line over here, what this particular operation is doing. Anyway, the choice is yours. Okay, how you're going to present it. But don't put comments for each and every line. That is not required. Okay. So that's question 3 of the thing that you have done. Then in question 4, they look into what is it called, number of days in a month, right? I mean, over here, you can tell me what is the mistake over here. Can you tell me? The mistake that I can see over here is the days, right? February can be 28 days, or it can be 29 days as well. Yes or no? Right? So if I put a variable like this, then I'll deduct mark, because I have got the opportunity to deduct mark. Because you cannot say days 20 equals February. Every leap year it is actually 29. So you could have said days 28/29, then I could have said, okay, that makes sense. So what they have done over here, they have created a list of 28, 30, and 31. And then they said, okay, please input one of the 12 months of the year. Now, keeping in mind that whenever they need to input, they need to input in this format. Okay, so either January, February, March, or maybe February, or maybe November. And then they will check that month whether it stays in the days 28 or not. If it is in 28, it will say it's a leap year. Okay, it says excluding, but it is a leap year. If it stays in the 30, then it will say that it's 30 days. And if that month stays in the 31, then it will say the month has got 31 days. So that means ultimately January, February, January, March, May, they have got 31 days. April, June, September, they have got 30 days. In that way, actually, you can add up. Amen. So in this is actually how you're going to add up. So all these things are there, they're checking from the list itself. So if that particular month is in that list, you can print that month. If that particular month is that list, and one good thing over here, if you remember, that this particular in function is very, very important, right? So they're going to check this month in that particular list. So this in actually tells us to check my source, which is month, to the destination, which is, so what they are saying, do that month exist in that list or not? If it exists, then it will print this value. Otherwise, you are saying input a valid month. So that means the month that was given was actually invalid. Okay. So you know that if and in condition over here, straightforward that they have done. Now, I prefer this one better. I prefer this one better because you are using list over here. Over here, what they have done, they have used else if, and they put everything in a list itself. Now, this is okay, but I should have put that thing in a list itself. Because, for example, if you do any typing mistake over here, the whole thing will not work properly. And if your list gets bigger and bigger and bigger, you cannot put all this thing in the one single line itself, right? Now, for this one, there's only 12 months. But think about if I'm talking about 365 days or 365, yeah, I mean, 7 days a week. If I look for each and every day, then you cannot put all this thing in one else if command, right? Rather, you can put a list. Although this is correct as well, but I will see that this is much, much better than this one because they created a list and then we are checking the values from the list itself. So same over here, they have taken the string, or one good thing they have done, they have taken the string actually. So over here, they have taken a string as an input, okay? And then they're checking that, is it February? So it's a hard code, it's February 2029, else if it is there, this one, December, this one, or please type the correct month. So again, same sort of thing, they are checking the string with the particular list that you have given, particular in condition in the range that you have given, they're going to check that. And if it exists, then it will say this 30 days or 31 days or 28 days, or it will say type the correct month. Both of them will work perfectly all right. But to me, I prefer this one better because it's much more clean, sort of, they have put that thing in a list itself. Okay. And one more thing you can see, if I need to write number of lines again and again, if I need to do a lot of operations again and again on month, in this case, I have to write these codes again and again. But over here, I just need to call this list again and again. So the difference between the number of characters and the code that I'm going to use will be much better if I use the previous list function. So this is another example of particular solution in, I think, week 2 or week 3. We also did something like this, that write a program. So it will keep on taking numbers and until unless it hits enter. Once the user press enter, then it will add all the even number, it will add all the odd number, and it will give us the numbers. Now, this similar sort of things we'll be doing as a part of your assessment as well. So I put even number 0, odd number 0, user input 0, that's fine. As long as my user input is not equal to enter, remember, not equal to enter, it will keep on working. Okay, it will take the input. If it is not equal to enter, then it will convert that input into integer. It will check for whether it is an even or odd. If it is even number, then it will add to the even number. If it is odd number, it will add to the odd number, and it will keep on going until and unless it presses the enter. Once it presses the enter, it prints the new line. The sum of the even number is even number. The sum of the odd number is odd number. That's it. The best way to learn code is that, okay, tell me how many of you understand these things? I mean, I'm going a bit fast. Are you understanding all this? Clear? How about these guys? How about this side? Clear? How about online students? I would like to know, I mean, are you understanding what I'm saying? I mean, I'm showing you all the revisions. Is it clear to all of you? Can you get it? What I'm saying? Okay. Now this is actually a good of a very good confidence, my lord. I have got 74 students online, my lord, and I got, it's a very popular class. Okay, that's good. So it's actually a really good thing that when I go fast and you keep track of what I'm understanding, that means you're understanding the whole concept. I mean, I don't need to go each and every individual line. This is week 5 of the semester. Now I can say I'm confident enough that even if I give you this small codes, you can easily find out what this code is about. This is actually the skill that will come to you automatically. Okay, but the only thing is that you have to practice. If you don't practice, then you'll forget the code. Look, I have already solved nearly about 6 to 7 problems or 5 to 6 problems just in 5 to 10 minutes. I went, but if I would have solved this thing in the first class, these 5 problems at least 20 to 30 minutes I would have taken, right? Now this actually shows me that you understand the code, and this actually helps me as well, because if I cannot do that thing, then from week 6 when I'm going to run, when I'm going to see 100 lines of codes, 200 lines of code, I'm not going to teach you each and every line. What I'll do, this is a block of code, it does this thing, tick 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 tick. So this is the thing that they understand, that this is the next block of code, these are creating the sprites, or these are creating the animations, or these are creating the what is it called, characters. This is a block of code that is used for jumping. This is a block of code that is used for running. So all these things I will just tell, and you have to do it by yourself, because it is not possible for me to explain 200 of lines of code in a class itself. And if I do that thing, your software application development will not come into play. So my first recommendation will be that from today onwards, you start working on assessment. Okay, I'll be talking about the assessment as well. Today onwards, you start working on the assessment. Hopefully, from week 6 onwards, you're in a better position that, okay, we are ready for application development. We'll start with that one. Anyway, let's continue. Okay, this is another one. Same with a different solution. So they have given a sum as 0, odd as 0. They have taken the input as an enter, or they can say that as a quit, you can put an enter to quit. As long as it is not enter, it will convert it into a floating point. It will check, is it equal to not equal to 0? No, then it will be odd. If it is equal to 0, then it's even. And then again, it will take a data input. It will check again as an enter or not. Then after that, if it is enter, the whole thing will execute, and it will say sum of the odd number is sum. New line, sum of the even number is sum even. That's it. So they have printed everything in one single line. Much better, much stronger way of. Previous one, what they have done, they have used 2 separate lines. I could have easily put a new line over here, couldn't I? And then I could continue that one as well in a one print statement. But over here, what they have done, they have used one single statement print, and they put everything in one statement. So that is also fine. Okay. And then over here also they use floating, and over here they use integer value. Over here they look for in the top one they look for even number, and in the bottom one they look for not equal to 0, which is odd number, right? If it is not equal to 0, then it's odd. The previous one, if it is equal to 0, then it's even. So same operation, they have changed interchangeably. So this is another one that it will be looking on. In your assignment, there's a question called prime numbers. There's a question about prime number as well in your assessment. And we have already done that thing as a part of your work as well. So this is actually code that is used to check whether the number is prime or not. You know actually what is a prime number, right? A number that is not, a prime number is a number that is only divisible by 1 or by itself. Okay, then that is called a prime number. Yes or no? For example, 7. 7 can be divided by only by itself by 1 or by 7. Yes or no? But for example, 10, it is not a prime number. Yes or no? So if I ask you to give a prime number, how you to check whether the number is a prime or not? So what they have done, just you know that if n equals to 1, then 1 is not a prime number. That you know already, right? 1 is actually not a prime number. Then anything from 2 to n, so that means 2 to 7. If I'm looking for 7, any number from 2 to 7, if any of the number is equal to 0, then it is not a prime number. Else if I equals to n minus 1, that means when the n goes to 7 minus 1, which is 6, okay, then it is a prime number. So until and unless, so if I start from, so if I want to see, if I want to check for 7 as a prime number, I know that 1 is not a prime number, I'll leave it. It will start from where? From 2. 2 to how much? N minus 1, what is that? 6. As long as 7 is not divisible by 2 to 6, I can say it is a prime number. So what they're doing, they're just checking every time whether it is, because it goes to 2 to n, which is n minus 1, right? 6. So as long as it is not 0, it will say fine. And then if they found that, okay, I have already reached 6, which is n minus 1, which is 6, then I can say that particular n is a prime number, which is 7. 7 is a prime number for me. So this is a classic example of a prime number. If you haven't done it, just check it by yourself. But the concept is, I get the number, then I started from 2, 2 to n minus 1, which is 2 to n, which is actually 6. N minus, it goes till n minus 1, you know that. So it divides 2 to 7, no. 3 by 7, 7 by 3, 4 by 7, 7 by 4, 7 by 5, 7 by 6, it doesn't work. If it doesn't work, then once it comes out, if n I equals to n minus 1, that means the total one that I've got, I is, which is 7. If I equals to n minus 1, which is 7 minus 1, which is 6, if I equals to 6, then n is a prime number. So it says that any number that is not divisible by 1 or by itself is actually called a prime number. So this is a simple code that you can use to find the prime number. Anyway, look into that one as well for your prime number detection. Then this one, I would like to keep it to you to understand. I mean, I think I have given this program as well, where you have to do what? You have to say 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, and 5. So write a code that actually can print this value in this format. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Now, I have already written a small solution about it. Okay? I've already written a small solution about it. What I will do in the next class, I will ask you what you have understood from this solution. It's a very simple solution. Very simple. I'll just give you just a simple hints. There's one for loop outer and there's one for loop inner, right? So this is one loop and this is one loop. If you can maintain that two loop properly, the whole problem is solved. The inner loop prints 1 and 2. The outer loop prints the whole outer phase itself. Have a look. Just try to understand. Put a table. What is I? What is J? What is printing? Just put that thing. Spend at least, if you cannot do it, spend at 30 minutes. If you can solve it by yourself, this is a simple solution. If you can solve it by yourself, that means you're understanding the logic. You'll be confident enough that you can understand the logic. So I'll keep it for you. Don't expect, I mean, if I teach you everything, then you'll not learn. Very simple problem. I mean, there is no syntax that you don't understand. You know that A is an empty list. There was an empty list. A dot append. I am actually appending. What I'm appending? I. What is it? I. I is from this range 1 to 6. So I already know what is I, what is append, what is A. Then there's no problem for me to understand this thing. Okay? Keep a try. Give a try and just see there's also a new line print. This new line actually takes the cursor to the next line. You understand everything. There's only 1, 2, 3, 4, 5, 6, 7. 7 lines of code. It is your duty, not as a group, as an individual, go home today and then solve this one before you go to bed. Okay? How this answer has come, I'd like to see. Okay? This is for you to understand. The last one was actually something called, what is that called? That get a sentence and then find out how many characters are there, what is the letter, and what is it. Now these are exactly what actually Samarpan has done actually. So he looked at this type of thing and the problem that he has given was pretty much similar to that one as well. So I'll show you that assignment as well. Now the question is over here, if I get all the thing as a string, so we can find out the order of that particular character. If it is between 65 to 90 or 97 to 122, we can say these are letters. If it's anything between 49 to 57, you can say it is a number. And then you can say what is the letter and what is the digit. That's it. Any character value between 65 to 90 is capital A. to Z, and 97 to 122 is small a to Z. Yes or no? So you take each and every character at a time, okay, and check it in which range it is falling. If the character is falling between 65 to 90 or 97 to 122, I am saying this is a letter. If not, if it is falling between anything from 49 to 57, which is 0 to 9, then I will say it's a digit. So this is a number. So finally, I'm saying how many letters and how many digits that I have got. Simple, straightforward. Now, those who haven't done that tutorial yet, here is a tutorial solution for you. Okay, you can go home and practice those tutorials, but it is not actually good practice. I really don't feel like to give tutorial solutions because that actually don't push you guys to solve your tutorials. But those who have solved the problem, those who have finished the tutorials, they don't need to worry about this particular tutorial solution. Clear, guys? Understood? Understood? Very good. How about online students? Clear? Right. Yeah, you can use, very good, David, you can use is alpha, is digit, definitely you can use. Look, we know what is alpha and what is digit as well. You can definitely use that thing as well, and then you can go from there. Okay, so that will wrap up our whole week 1 till week 5 courses, right? So this is pretty much an end of the first module of my Python. Okay, now what I'll do, I'll give you a 10 minutes break. At 6:20, I'll start with the assessment questions. Okay, I'll come back with the assessment and I'll teach you how the assessment looks like. Okay, clearer than my future. Good, I love it. Thank you. Okay, I will see you in 10 minutes time again at 6:20. Okay, and we'll start with the assessment part.